Hello, hello. Can you hear me? Can you see me? Am I too loud, too quiet? Looks, it should be same as last time. The cat is up. Maybe she's unhappy that I'm talking. We'll just get going here in a couple minutes. We'll say hi to folks who are in the chat. Sorry, oh, I always get the wrong. Cat cam is being finicky as always. We'll see if it works a bit quiet. We'll see if it works a little bit later on. I don't know. I don't understand why it doesn't work. Who knows? Okay, a little quiet. Although I sighed and I got up in the red, so let's wait a little bit longer. Vin is like, why are you talking, Dad? Hello, Dave. Hello, Beata. Thanks for hopping in and watching the stream. Excited to get going. I've been doing a lot of housekeeping because I was out most of this week. Do you want to go out, Vin? All right, I'll be right back. Let this cat out. All right, go. If you watched our streams before, Vin, one of the two cats, she likes to knock the garbage over when I start talking because she'd rather me be quiet. All right, so we're just over time, so we might as well get started. So, hello everyone, my name is Scott, and I work for Adafruit on CircuitPython. Adafruit is an open source hardware and software company based out of New York City, but I've worked remotely for them for a while, since 2016, so 7 years. Sorry, I'm in the wrong channel, or the wrong Discord channel. Hello, Clever. Hello, Deshipu. Totally lost my train of thought. Adafruit's in New York City. They pay me to work on CircuitPython. If you want to support me, support them because they pay me quite well. And you can go to adafruit.com to support them. Buy some stuff that you see here, all the little toys and gadgets, and a lot of them run CircuitPython and make them really useful. So devices are a two-part game. They're both software and hardware. So like I said, CircuitPython is a Python version for microcontrollers. It's based on MicroPython. It's meant to be really easy to get going and run code and make some microcontrollers and whatever it's connected to do something. So hello, Gerard, and hello, David. We'll get to the ESP32 stuff here in a little bit. I always like to take questions and go off tangents as well. Hello, DCD as well. But a bit of an update. I mentioned last week that I was looking for office space, and I've signed a lease. I get the keys next week, which is exciting, so I won't be streaming next week. Foamy Guy will be streaming in this spot instead. So keep an eye out for Foamy Guy next week, 2 p.m. Pacific. I think he does the same time here on the Adafruit channel. And then I'm hoping that by the next week I'm like in the space enough that I can work from there. So it's like a mile-ish away from here, and it's going to be a very different thing because I've actually worked from home since 2015. So it's going to be really weird. But it should be a good commute. I don't have to drive. I can walk it if I want to. So I'm looking forward to that, and we're looking forward to getting this space in the house and fixing it up, and then using it for other stuff. So yeah, these deep dives tend to run about 2 hours. I have a bit of a cold because my 1-year-old's in daycare. So we may just go the hour. We'll see. We'll see how I feel and how we're going. Are there any questions from folks watching before we kind of dive into what I had in mind? Is there another baby on the way? No, there is not. There is not another baby on the way. I can see why you would ask that question, though. Hint, hint. We might choose to. We haven't decided yet. If folks have, talking about the new office space, if folks have suggestions for maybe like, I could do green screen behind me, but I could also do like some sort of like setup or sorts of stuff. So if folks have ideas for things that should be behind me during a stream, let me know. I was, part of the reason my brain is gone is not only do I have a bit of a cold, but the last few nights I've been like having trouble getting to sleep because I've been just thinking about all the things that I have to do for the office move and what I want in an office space. So it's been going quickly, and I'm looking forward to being moved into the other space. David asks, on the I2S library, does it do both left and right channels? Yeah, so the audio system in CircuitPython should be able to do stereo. And if it doesn't, if you have a mono sample, it will just copy over to both channels. So I2S will always have two channels, but if it's a mono sample, it will do the same sample to both channels. Eric asks, how big is your new office? Good question. So I was looking for something about the size of this room, but maybe a little bigger. So this room is like 10 feet this way and like 16 feet this way, including the closet. So this is actually like a bedroom. So there's a closet to my right here that has a bunch of electronics and old Game Boys and that sort of stuff in it. I've got like a bunch of like tons of Adafruit hardware, tons of dev kits, that sort of stuff. So this is about 160, and the new space is just about that as well. It's a little more square than this room, so we'll see. And it's also got a bit higher ceilings, so we'll see how that goes. Hopefully I can fit everything, because I'm probably going to bring a couch with me, so I'm actually going to have, that's going to be a bit bigger of a thing. Clever said could do both, a green screen on a pull down curtain like a projector screen. Yeah, I think a green screen was probably a good option. Phil, PT, who does Adafruit, suggested the Elgato one that they use. So I might just get that just to have. We'll have to see how much I fill up the space. David says, do you need to duplicate the computer, or will you remote connect or totally not work when at home? I think generally I won't work from home, and if I do, it'll be on a laptop, because I won't have a space. I won't have, at home I won't have a monitor and keyboard and stuff. It'll be on the laptop. What about the cats in your now office? Dave asks. The cats will stay here at home. So I think in the short term all the cat stuff will stay here and they can hang out in here. But we are looking, like, there's a roof leak here that we've tried to fix numerous times and we haven't managed to. So something that we're looking to do is just like completely like take all the drywall off so that we can finally figure out what is wrong, and maybe redo the roof above this room as well, to finally hopefully fix that. So the cats will stay here. They won't go with me to the new office space. And it'll be a big shift for them. I think that's one of the main things I'm worried about, because like they are like 9 years old. So I've been here 8 years. It's only been that very first year when it wasn't even a full year, where they had the house to themselves. So we'll see how they do. It's been a lot of changes having a 1-year-old around the house too. Like Ari ran in here this morning and Spook hissed at it. It was this morning or last night. So Spook like hissed him, and Ari was just like trying to pet him. It was like, Yeah, figuring that out. Clever says, no more cat cam then. Yeah. I don't think I'll do, yeah, we won't have cat cam. David similarly says, why did you recently invest into a new cat cam then? Well, I bought a used cat cam, and I didn't know exactly when I would be, moving. I just, like, I didn't spend on a really expensive thing. I will have kind of a view, so I was thinking about, instead of cat cam, doing like window cam out the window, like weather cam, but we'll see. I don't know. That's why I'm trying to like rethink kind of like the setup on the sidebar here this way. Like rethink that setup and maybe green screen as well, right? Like if I green screen it, then we can do other stuff. Besides that, I do want to get, like, I have a big desk here and then I have this desk behind me. But I do want to get another desk I could have kind of to my side to hold like debug probes and stuff like that. And the hover cam, like the top down camera that I've got, it'd be nice if I could do that kind of more permanently. So I think that's something I'm thinking about too. Yeah, be careful with attic spaces and insulation above rooms. Yeah, I think we'll probably find somebody to do it for us. Set up a cat cam live stream on its own channel and then embed it. I think those probably already exist. I don't know if we need these kitties. These kitties here, although Spook is quite cute, for sure. And that's what Dave is asking too. Can you do a remote link to cat cam for your office? So do you all just watch the stream for the cats then, I guess? Anyway, yeah, so it's going to be exciting. It's going to be good. Right now, Ari's daycare is a drive away, so we're doing a lot of driving back and forth to daycare. But when he turns 2 or is about 2, we should be able to switch to a daycare that is walkable or bikeable. And it's kind of like this new office spaces between the two. So there's a future where I'm able to like drop him off and walk to the office and do all that sort of stuff, which will be quite nice. But right now we're driving, so we'll see. DCD says, I'm here for the technical content. All right. Well, let's take that as a segue. And like I said, find me in Discord if you have ideas for streaming setup and things like that. I was thinking about getting a second light, for example. I don't know, it might make the lighting a little less shadowy. I'm continuing to look at my camera, or not at my camera. Yeah, so find me on Discord. If you're not on the Discord already, you can go to adafru.it/discord, and we have the live broadcast channel there. And then we also have CircuitPython Dev. Those are kind of like the 2 main places. Ooh, so we've got a question. Ratia says, I've made some deliberately vulnerable web apps in CircuitPy for the ESP32S2, and I want to eventually do the same with the S3 and have an app using Bluetooth to set up the vulnerable app. I found the way CircuitPython handles writing to the disk makes it hard to create a setup Wi-Fi AP where people can add their Wi-Fi credentials to allow a CircuitPython project to persistently join a Wi-Fi AP. Our expectation is that when people load CircuitPython, that's when they load their credentials. So that's why CircuitPython doesn't do the like join my AP sort of thing. That's one reason. The other reason is we don't think it's a very good user experience because you tend to lose internet access when you do it. It's pretty clunky. So our focus has been like when you get CircuitPython on it, you also provision the credentials. And if you see like the web serial loader that's available on circuitpython.org/downloads, like it can save the Wi-Fi credentials to your drive for you as well. So that's kind of like what our approach has been to it. But if you have changes you'd like to make to CircuitPython to make it easier, we're totally open to that as well. All right. So the thing that I wanted to at least start with talking about today, Bettina says, I wish I could make an IoT setup page to configure once and let a honeypot or vulnerable app I'm teaching a lab on work after the first run, but I understand. Foamy Guy says, one option is you could store credentials in NVM storage. I've used that type of mechanism before for end users, configurable Wi-Fi. Michael Bishop says, something I don't see people using enough, you can put a Wi-Fi name and password into a QR code, but then your device needs a camera and the ability to scan the QR code. Thank you. I was just wishing a self-hosted page could save something like credentials to the disk. Yeah, web pages should be able to write to the disk, but like the web workflow won't start until you have those credentials. I've not done much access point stuff. David points out there's a tiny code reader from useful sensors that reads QR codes and can be talked to in I2C. All right, let's we'll keep chatting. That's no problem. But let's move on to this bug that I told Kattni I had looked at today. So here's the issue. It is issue number 8288 if you want to follow along. It's the Metro ESP32S3 Watchdog timer expired safe mode when various demos. And you can see the different versions here. Here's a very basic code.repl, which seems kind of bad. So we'll try that. Here's the original demo. Here's the I2C pin identifying script. And it also has the same issue. So I had a theory when I was thinking about this, but I was only thinking about the second example. This first example doesn't go towards my theory. So sorry, I'm a new parent. So I have a Metro S3 here. It's a prototype, but I wanted to see if I could replicate it. So I've the first step to fixing this issue, and I think Kattni's been hitting this a lot. So this is why I want to take a look at it and figure out what the issue is. So the background is that there's a couple watchdogs that run. And one of them, I'm trying to remember, it's been a while. I think there's one that's interrupts, so like making sure that the interrupts aren't blocked for too long. And then there's a second one that is yielding to the idle task, if I remember right. So in CircuitPython, we have to basically like give up our freertos tasks so that the ESP IDF can run other stuff. And if we don't do that often enough, it will raise this error. So that could be it. So the theory that I had, so the other example is like searching through all of the different I2S pin combinations. And in that case, you're going to be generating a lot of objects. So my theory that I'm coming into this with is that somehow on this board, which has 8 megs of RAM, we're actually filling up the heap, and we're doing garbage collection. And when we do garbage collection, we're not yielding back to the freertos enough to satisfy this like internal watchdog. So that's my theory, but this first example that fails doesn't match that theory. So let's see if we can replicate it. I've got, what I did before is I did get a new branch going. This is up to date with the latest CircuitPython as of today. You can see this new board from Deshipu, I just merged in, so we've got that. Other things of note is that, so this is not the IDF5 update. This is with IDF4 still. And it is, this has the MicroPython 119 in it. Now, I think, Kattni might actually be working on, so this 756, C756. It's possible she's on the, hello, Unexpected Maker. Yeah, we're trying to hunt down this watchdog timer expired safe mode problem. She may be on the 82X branch, actually. Let's just take a quick peek here and see if we see it. See those commits on the 82X branch. So one was C75. 756 is in both of them. So there's one. Yeah, so she's been doing these like pin definition updates. So it's possible we won't be able to replicate it on main, although I don't think main has changed that much. So we should just start it. Let's just see if it has a problem first. So I'm going to press the boot button and then the reset button. And now I'm going to make flash. Oh. There we go. So this is not a debug build. First, we're just trying to replicate the issue, and then once we replicate it, we'll start debugging it. If it's not present on 824, then is it a problem? Does it say it's not on 824? Did Kattni say that? It's not clear to me that it's not on 824. 824 would be somewhere near the newest branch of hey DJ Devin 3. Okay. So we flashed it. Now let's hit reset. I don't even know what's on this board. And we got the bootloader. Metro S3 boot. I wonder why that is. This should have copied over all of it. Let's try it again. Test on the stable release first. If we can't replicate it on main, then we'll try it on the other branch. I don't think a lot has changed though. Okay, that looks like the bootloader still. Yeah. Huh. I don't know why we're just getting the bootloader. Let's do a clean. And flash. Maybe we need to wipe it. It should be able to find the like second. It should be able to find CircuitPython. This is how I usually do ESP testing when I'm working on it, is by using this flash command. So I'm looking in the Makefile just to see like what the commands are. Partition offset, UF2 bootloader. Yeah, see, so Flash should be... Yeah, it should be doing both, because there's also this Flash CircuitPython only. So it should be flashing everything. We'll try it one more time. I was going to say it's been a minute, but... I picked up a Metro S3 N16R8, so N is flash, R is RAM. Like that it has a built-in SD card and gobs of RAM. Yum, 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 more RAM. Have you seen this issue at all, DJ Devon 3? Have you seen this Watchdog timer problem? I haven't seen it, but I've also not been doing a lot of testing. Most of what I've been doing is either IMX work or ESP compilation stuff and configuration for the IDF update. Which I set myself, my goal is to get a PR out for the IDF 5 by Wednesday, the end of Wednesday next week, because Thursday is when I get access to the office, and I think I'm going to try to move all that like over the week, over the long holiday weekend. It's a holiday weekend in the US. So it built, and it's flashing. And then it stays in the bootloader, and we hit reset. And now we're in the UF2 still. I don't know why that's not working. I wonder if I have a different... I don't have a production version. It's possible that's the problem for me. But I don't think it should be. I wonder what happens if I just copy over the UF2. Because it should have built a UF2 as well. Metro S3, firmware bin elf. It did not build a UF2. Oh yeah, unexpected maker, you came late. Yeah, I'm moving my office out of the house so that we can fix up this room and use it for other stuff. So I've got a lease, and I get in there on Thursday of next week. I pay for one day's worth of August. They billed me for August 31st. Okay, why aren't we getting a UF2? That seems very strange to me. But oh, I guess that's because we're doing the flash target. If we do the regular target, it does the UF2. Okay. So let's copy there. This used to work, and now it doesn't. Okay, so now it's copying over. I can see the NeoPixel flashing. Never used Watchdog Timer. I did see the reported issue on it, but have nothing to add. Yeah, so this doesn't require you to use the... Yeah, see, it just went right back into the boot. Is it because I'm... I don't think so. I do have... I do have this connected already. Okay, it doesn't get anything. We're only getting the bootloader, huh? That seems strange. Let's do debug. Actually, we'll put it at the end. Let's do a debug build and see if we can't get some output. Oh, I just cleaned already. And I'll reset us back into the ESP bootloader. hard faults on matrix portal S3. So maybe the next thing we do is we switch to the 8.2x branch, because maybe my stuff is not working for some reason. Like maybe it's been fixed there but not on main. Although 8.2x got merged into main not too long ago either. We can switch if we want to see. It's possible this is a separate problem that was just broken. Main is pretty main is where we're starting to work on 9.0, and we have turned that corner because Dan and Jeff did the 119 MicroPython merge, which is great. And we want to do the 120 merge before we start like calling it 9.0 officially, because the MPY versions will change with the next merge as well. So if you are using main right now, you'll have to use the Python version of libraries. We don't have MPY files currently for main because it's going to change. Otherwise, once we're settled on the MPY version, we will do all of the tooling for 9x stuff. All right, we're flashing debug and we'll see if we get some output. We should. It's labeled TX. And the IDF upgrade too. Yeah, we'll do the IDF upgrades in 9.0 as well, but it's not blocking us like making all the MPY stuff, like the bundle and 9x bundle and stuff. That's blocked on the MicroPython stuff, not on the IDF. The IDF upgrade should be more internal than the MicroPython one. Okay. So we're still getting the bootloader, and we're not getting we're still not getting output. So let's do ESP tool S3. I want to obliterate it. Erase flash. It doesn't feel like, to me, it doesn't feel like it's sticking. That has me worried. There are a few warnings during the build process. Does your CI process force warning clean commits? These warnings tend to come from the IDF, not from CircuitPython. So we end up being stricter about CircuitPython code than we do about the library code that we're using. DJ Devin 3 says, I'm generally excited for 9.0, but it's going to get messy on the way there. Yes, it will. Oh, I selected the wrong device. We don't need the Silicon Labs thing. We want the espressif JTAG. All right, we'll erase the flash, and now we'll do debug flash. And if this doesn't work, then we'll try doing 8.2. Okay, let's hit reset again. Oh, there we go. So I got I'm getting NeoPixel blinks like it's CircuitPython now. And there's the CircuitPy drive. It took a while to pop up. And we're still not getting any output on here. Did I not connect it correctly? I think it's correct. Although, who knows if these wires that I've got going to it are good enough. It should, I don't know, actually I don't know if this board during debug will automatically do debug output. So Adafruit Metro S3. NeoPixel's working. Double tap. So one area of optimization is, I think a lot of, well, this is for flash mode, but I'm not convinced that we've actually optimized the flash settings, the flash and RAM settings for a lot of these boards, a lot of the ESP boards. Okay. Where do we do the console? Yeah, so this is 16 megs of flash. It's an N16R8. Takes a while to boot and appear with a 16 megabyte of flash. Yep, I think that's part of it. And that could be the source of this problem too. Like some sort of housekeeping stuff is taking forever. Okay, why aren't we getting... Is it because we're not... I'm expecting to get debug logging out. ESP IDF has untracked content, but it looks pretty clean. What other boards would have this? Ah, here we go. This is what I'm talking about. That's what I'm thinking. Never reset these pins. 43, 44. Metro S3. Oh, I should have copied more of it. Yeah, I wonder why it takes so long. Have you investigated that? Okay. Ooh, just in the nick of time. I would love to fix this issue. Staying in bootloader. And we're still not getting any UART output. Here we can see is, oh, TX and RX are 40 and 41. But I have it on 43. Oh, there's debug RX and debug TX. Where are those? Oh, you know what? I think those are... I'm looking at the board here, and I have an older board. I'm plugged into the wrong place. Let's pull up What's new? S3 Metro. Yeah, so I have older silkscreen. But I'm connected, currently I'm connected into this TX here, when I think I should be actually here. There's this little debug label there. So if I just do, I don't have a great way to connect to it. And this is something that I'm gonna have to figure out because it's like, I need to solder onto those things, but in my new office space, I won't be able to solder. I don't know which one's which, so let's just do that. It's not that one. There we go. Great, now I'll just hold it. Ooh, actually, I can bring out my big stick. This thing. Yeah, I could take the solder projects outdoors to do minor changes. Oh, you know what? No, it's not, David. I know what you're talking about. There's one one board with a switch for switching it, but I don't think it's this one. Yeah, so I'm just connected to the wrong pins. So let me see. This is what I'm thinking I need a separate thing for. Is that if I had a separate desk, I would have more space to set up this like jiggy thing. And then I don't need to solder to it. Sorry, you can't see. That's another thing I'm thinking about. How you'll be able to see. Okay. Stick that right there. All right. We have error messages. When I brought it up ages ago when we were receiving the double starter CircuitPython over mounting, I was just told it was something OS related, so I never looked further. Yeah, let's just take a look. So this is TO modes. So these are timestamp modes, and it's super handy because now you can see like how long it's been between messages. For like you can see the timing of these are prints based on the NeoPixel flashes when it configures the pin and when it deconfigures the pin. So you can see the amount of time that is happening between the flashes and how much time is spent kind of flashing. Which is pretty neat. So maybe what we do is we'll just I'll just hit reset here so that we can get all of the messages from the start. And then we'll just take a quick look at the timings of it. So this is the bulk reset that CircuitPython does. This 1 second is probably the 1 second safe mode wait that CircuitPython does for all boards. Do not use for mass production. Timing parameters will be updated in future IDF version. Cool, 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 cool. Yeah, and so this 2.3 seconds is not. is just the difference like when I press the button. So I don't actually see, like the SPYRAM test took almost half a second. I think this 1 second is probably the safe mode link, but I don't see any others here that are significantly, like, that are long. Oh, here's, you know, this 5 seconds is just the blink pause. Is reset the same as power cycle? Maybe not. Should we try a power cycle? There's a, let's do that. So I unplugged it. I'll plug it back in. It still seemed pretty quick. It was just like the first time after the flash seemed pretty slow. And like if you erase the flash and make a file system on it, like it does have to do like add all the like fat FS housekeeping stuff onto it. So yeah, I don't immediately see anything of note. So let's go back to the original problem, and we'll keep an eye out for any slowness. But Kattni says that this basic example causes this internal watchdog expired timer, which basically means it's getting wedged somewhere. So we'll mount, and the mount takes a while, but I feel like that could be like the host computer takes some time to, the host computer takes some time as well. So I think we just hit the restart that Kattni saw. I briefly, like, here's the PSRAM warning again. Yeah, and you can see that both CPUs were reset by the watchdog. And this TG1 watchdog sys reset was hit. So we are able to reproduce the problem that we saw with that. And looky here, we have a saved program counter, which must have been the program counter when the watchdog timer occurred, maybe. So let's just take a quick peek at the, so this is me pulling threads and seeing where they take me. So let's open up the build directory and we'll look at the firmware map. And we're looking for 4037, which doesn't, oh no. So basically we're getting stuck somewhere. And the question is why? So that's very weird. So I don't see, 420. Yeah, I don't actually see that there's any code at 403. Let's look at the linker script, which I guess we get from the IDF, which is annoying. ESP IDF, do we get the linker here? No, unfortunately. So I don't really trust that. I've got my ways. Does CircuitPython do any JIT? No. It's not that smart, I don't think. Cool. Well, I'm happy that we're able to reproduce it. I'll tell you that much. So let's see, like we're off in the weeds. I don't trust that. So let's figure out where we are in CircuitPython. So I suspect, and we'll just do that by adding ESP logs. The code.py here is this digital in-out creation, which should seem straightforward. It should work. It's a very strange, this is a very strange issue. But it could be like some sort of memory balance thing. Okay, so common how, digital IO, digital in out. You know, this could be some sort of like cache issue. So here's the construct call, and this is what happens. It's been a while since I've done the care tag. Is that what it is? CP. I think so. Let's try it. So I just press the buttons to enter the bootloader again. I'm only changing CircuitPython files at this point, so I can just rerun this and reflash. And there's the output we're getting from the bootloader, the ESP bootloader. Oh yeah, I have objdump. I'm just not using it. You would have to know which one to use. Like there's an extensive version, but there is objdump. I could also try to do like address to line. Okay, we flashed, so let's start up again. And it looks like we're boot looping. So when we boot loop, I want to just get it back into the bootloader. Reserving 0 bytes of PSRAM. So we have to remember that DIO construct. So I don't think it's getting that far. It could be an issue. Right, so here's the load. Here's me pressing the button. We go along, we do the DIO construct, but those are not, these are DIO constructs for the blinking. Like we're not actually into code.py yet. Code.py yet. And then we get to this reserving 0 bytes of PSRAM, and then we hit the watchdog. So let's add another, let's call this DIO, and then let's copy this. So the other place that it's doing it is bus.io, and it's spy. And we're doing spy construct. that. I don't think we shouldn't be. We should get down here. Okay, so let's try that. So what I'm doing is I'm trying to figure out where in the flow that the user code prompts are we getting. And basically like follow that down until we figure out what is. So the problem, the watchdog issue is the problem that you're getting into somewhere that you shouldn't. You're getting like you're not going to the code that you need to go to, or you're not like you're hanging basically. You're preventing everything else from running. Digital in out. Oh, it needs to be static. So this tag thing is like the prefix that you get, like the I2S or ESP IDF is what the tag is. It allows you to like filter to see messages only in a particular module. My sinuses are getting stuff here and stuff here. They were actually pretty good. I went for a run. It's like pretty clear. Now they're getting gummed up again. Okay, so we've loaded. And let's hit it here. And now we're boot looping, which is interesting that we're boot looping because we're not, you know, the next time we start up as in safe mode, we shouldn't rerun the problem. We shouldn't rerun the problem code. So we got construct and construct done, but we didn't get to the digital I/O thing. TG1 watchdog timer. Maybe like there is the earlier DIO construct. Let's look at the IDF source or the docs. This should tell us which watchdog is used as what. See, there's like this int watchdog timer and this task watchdog timer. I don't want maximizing execution speed. Watchdogs, this is what I want. Make sure the freertos task switching interrupt isn't blocked. Runs in an infinite loop with interrupts disabled or hangs at an interrupt. The default action of the interrupt watchdog is to invoke the panic handler in timer group 1, so TG1. And it will be the display. I thought we should have the panic handler on there. Can you disable the watchdog and observe correct behavior? Good question. The other thing I've seen is that you can actually change the timeout on the watchdog. The task watchdog timer, I don't think we have on. I think we turn it off. Hi, Dinkelberg. I could be wrong. Check idle task. And we're not getting the panic handler. Jacques Wilson says, thanks for doing this. Sorry I joined late. To get me up to speed, what program/problem are you trying to troubleshoot? So we're doing CircuitPython. We're on the main branch, and we're running this code. It's Adafruit CircuitPython issues 8288, and we're running this seemingly simple code, and it's causing a watchdog timer to expire, which is weird. We're trying to figure out why. So let's just see. Let's take DCD's suggestion and let's see if we can't. Oh, component config, core dump, log output. I don't know where it is. Did I mention how I really dislike kconfig? See, panic handler is supposed to print registers and halt, but somehow we're screwing it up so much that it's crashing. So here's the interrupt watchdog, and it's got a 300 millisecond timeout. So here what we could do is we could just say 600 or 1,000. So let's set that to 1,000. Let's place the panic handler code in IRAM. Maybe that will maybe if we put the panic handler in RAM, we'll actually be able to run it. Okay. So I think that works. Now I'm gonna do a clean, because if you rebuild, it won't rebuild the IDF code, but the SDK config can impact it. No cat cams now. It's just watchdogs. Is cat cam working? Let's look. It is. It's giant. Whoa. I don't know why it's so giant. Properties. Resolution. It's in HD. How big is it? Properties. How do I change the size? Shrinking it down. Good. I was hoping we would have a cat cam for the final stream. The final stream with cats. Cat cam is big. Yes, it is. Oh, and it's frozen. Brilliant. It's big and it doesn't work. Because I moved it and it did not move. Oh, okay, well, back to the desktop. We'll check on cat cam later. I don't get why it says. I don't know what's going on with cat cam. Can't say I'm too sad about it, honestly. If I had a dog, would you call the cameras watchdog? Okay, so we're flashing. We'll hit reset in just a moment, and hopefully we can get the panic handler, because that would make things simpler. If we could get a backtrace, that would make it way simpler. So it looks like it worked. Oh, no, I jinxed it. I just pressed the button to stop it from resetting. So here we can see that they were reset by Watchdog timer. See, like boot mode is in dual. So like there's potentially a lot of optimization we could do. So like the SPI flash has modes of like how many bits come in at once, and DIO is 2 lines, QIO, quad IO would be 4, and then octal would be 8. And right now it's actually booting in DIO. I don't know the history of Watchdog. Okay. So we're still having this problem. And it is interesting that it's 3 seconds from the time that we do construct done to when it resets. We set the Watchdog to be 1,000, which is 1 second, but it may actually be like trying really hard and doing multiples of that. So let's just add some more logging and see if we can't, find how it gets further and further and further. The next place I think I want to log is in shared, like we should be getting this DIO construct because I think that last line is needed to reproduce it. So let's go into shared bindings and just see if we can get some more output there. Should be QIO for runtime flash use, DIO for when you're actually flashing the chip. QIO for flashing can fail quite often for some reason. Yeah, and I think that's why we're on these like safe settings, but there is totally room to optimize, I think, the actual runtime. I just don't know. Like nobody's actually done the work. So in digital IO, digital in out, there is a little code that runs before. So construct is where we have a print. And let's just do another, what do I have in my paste? Binding. Let's just do an ESP log tag, make new. And I also want to do, I'm going to do 2 birds, 1 stone. I'm going to do bus IO as well. So the one thing that's weird about the bus IO initialization is that it's using the like standard pinout, which we may have to, no, it just returns. Oh. The question is, where is it? All right, so we've got a couple more logs here. We could be in USB. It could be a USB issue. Actually, that's probably worth testing to see what happens if I disable the USB bus and then do it. I've got it active because I'm flashing the device over it, but I think we did see the timeout on we saw the timeout even when safe mode was active, and that's when it doesn't did not finish my thought. Safe mode doesn't run code.py. So maybe code.py doesn't actually matter at all. It could be more of a like issue with the flash. So it could be like flash reads take so long that we hit the issue, but maybe it's, so this is the ESP chips are very similar to the IMX in that like code is also, there should only be the one watchdog active. It shouldn't be two. Okay. So let's reset and see. There it was again. And we did get the construct done. Construct done, but we didn't get the, and it's 3 seconds still. Let's do the test to see if we get it without. So I have these cables that have the switches in it, so I just hit the switch. That means that it won't enumerate on USB. And I'm just going to hit reset again. Yeah, so it's still, it's run code.py, it's still hanging. And now it's doing the blink and it's okay. So it is code.py related. But what is it doing? So it could be background task related. So that will be my next guess. So like, you know, we're looking at the code.py and we're basically saying like, this is complete. This is finishes, but we never get to this next portion. We know that because we don't get those prints. Although there is a little bit of buffering that happens and maybe that's the issue. But let's just do a quick, let's go to background tasks and see if we are running background tasks while this happens. So background tasks are like housekeeping sort of things. Like filling audio buffers is one example. Rendering display IO displays is another. So it's possible that we're there. Maybe I need to try to JTAG connect to it. Maybe that would actually solve or help me figure this out. Background callback run all. BG. Start. Oh, let's do it down here. It's possible that like we're blocked waiting on some sort of lock. This will happen probably a lot. I don't think that PC is valid though. I think it went off into the weeds. This is why I want trace stuff. Thanks, Dave. Have a good night. Okay, let's see if we're in background tasks. So what we're gonna do, I gotta turn my USB cable back on. And now I'll flash again. And I only have to do a partial rebuild because it's CircuitPython. Oh, and I have to put us in bootloader mode. Do you have an MMU or MPU? I think there is an MMU, but I'm not sure. A lot of that gets taken care of for us by the IDF. All right. Ooh. That is more promising. Well, that looks separate because we're not printing out, but abort was called at a 403 program counter. Yeah. I don't know what's at 403. It might be ROM, actually. I could look at that. So this is good to document. So if we do this, we copy this backtrace, and we do Python tools, decode backtrace, Adafruit, Metro, S3, and then we paste that in. Heyo! It gets corrupted, but it is a lock acquisition that is aborting. I have a memory map. I could look at it. You want to fix this for me? Go ahead. Right, so this is a problem with a lock. And it's getting squashed. And then there's this 400-50965 address. Yeah, this Python script uses address to line to decode the backtrace. But 4005 I don't think is in our memory map, or in our memory map file still. Which could again mean that we're in ROM. It's so weird. It's so weird. This is a weird bug. Metro S3. Firmware elf map. 400. 4038E137. So the lock stuff is an IRAM. No, it's earlier than that. IRAM 007-400. There's DROM. Linker script and memory map. 307A. But this 4005 is still weird. Like 4005 is lower than that. You're executing code from IRAM. All the panic stuff is in IRAM. the stuff for it is not. Here we go. Oh. It says. Ugh. This is why I don't like other people's linker scripts. It's all this linker magic. Linker scripts are the worst. 4.2. Well, address to line couldn't find this one either. And we panicked even earlier. You know, we panicked. I think I want to just run it again and see what happens. I mean, I wonder if these PSRAM, is it the PSRAM problems? Timing parameters will be updated. Is that possible? Obj jump T, easier to read. Yeah, bug in the backtrace code. I can't unwind the stack. Yep. I wonder how we... You're assuming... Dingleberg says, I wish I could look at those lines of code and understand right away what's going on like you guys do. Like, no, I don't understand what's going on. Yeah. I wonder how we change the PSRAM. Do not use for mass production. Like, there's a warning there. Maybe it's... like, maybe we can find more info if we just find what this warning is. Do not use for mass production. SPI flash timing tuning. PSRAM 351. SPI flash IDF. Maybe this'll tell us what we actually need to use. IDF components. SPI flash. SPI flash timing tuning. $351. Here's the warning. Do not use for mass production. So... I don't know. Needs tuning. PSRAM needs tuning. What caused this? OPI-RAM, PSRAM. Hardware support. So maybe this is that we should just maybe we had to turn off like auto detection of SPI RAM. port S3 OPI PSRAM 265. PSRAM enable. Okay, so this just calls it, but this thing says do not use this. So instead we could get tuning config. Let's see if they've gotten rid of this. So let's look at their 4.4 branch. Components. SPI flash tuning. Interesting. So here, they no longer have that warning. If you were to bring a personal project to life, what development environment would you personally prefer to use for the ESP32 platform? I mean, this is kind of the best way I know. This is the best way I know how to do ESP32 stuff. I wonder if we just updated the IDF. PSRAM access failed when DFS is enabled. Add timing tuning. Remove 80 meg DDR warning for 4.4. Regarding timing tuning. So this removed it moved the warning. And basically if you clock it at 120 or 240, it'll warn you. And then, so they removed the warning. And then they added flash timing tuning index. And then they also say PSRAM timing tuning index. So it will output. Let's just update the IDF. It gets a little hairy because we have some fixes that we carry, which is annoying. But like, this is suspect. Actually, let's see. Let's see what this changes when DFS is enabled. Update IDF to 5.1.1. We're getting there. This is not, I'm talking about updating to a newer 4.4. Although, you know what? SOC SPI-MEM support timing tuning. We're still hunting. We're right now the theory is that our PSRAM settings are causing data corruption. And there's this bug fix that is ESP32S3 PSRAM access failed when DFS is enabled. I don't know what DFS is, unfortunately. Maybe it's like dynamic frequency tuning? What do we think DFS is? Merge requests. 2400. Let's just see what this is. Dynamic frequency scaling. Yeah, that's a good guess. Yep, dynamic frequency scaling. Power management. So we're like sleeping. Yeah. I mean, this sounds very suspect, right? Like, these changes seem quite relevant. Fix PSRAM timing tuning bug. Like, I'm not sure what of these we have. So maybe let's go Adafruit, ESP, IDF. All right, we got 30 more minutes. I think can I turn off the timing tuning in menu config? I think I can. I think I could. Yeah. Maybe that's what I need to do, is that it's messing it up. So I think I really get confused by you don't manage this well. Like, what branch are we on? I don't know. I thought it was this. And if so, we haven't updated it since January. 630. So we can go here and go to ESP IDF. Yeah, we're on 630. So we haven't updated IDF for 4 since the start of the year. So we have, you know, like 8 months worth of fixes that we don't have. So let's try it. Git remote add espressif. And now we want to git fetch espressif. That will probably take a while. Courtney says, maybe my question is not formulated the best. I saw the CircuitPython repo and personally I'm only familiar with C and the IDF framework. But I know a college that is working with MicroPython and I understand why it exists, but would you prefer it for personal projects? Oh, would I prefer CircuitPython over C? Yes. And I think, yeah, I mean, I have a bit of a trap personally for using CircuitPython for personal projects because I always find bugs and I end up just debugging CircuitPython, which is like my job. So a lot of my personal projects end up being kind of further afield and more Python-y than CircuitPython-y, unfortunately. Because anything that's having to do with CircuitPython, even if it's a project, I can basically call. I can call it a good. I can call anything related to CircuitPython work. Let's see. Fusing. Git fetch unshallow origin. I think not only is the development workflow for CircuitPython much easier, but also there we go. Hey, nice. The merge applied without complaining to me too bad. It is update init. What is the problem here? Oh, my init's in the wrong place. All right, there we go. Okay, so we've updated our IDF. So let's try it. Maybe it was fixed. So we're going to do a clean again. And I will get, am I in bootloader mode already? No, I'm in crash mode. The other thing that I was going to say why I like CircuitPython is that it's portable. So like a lot of stuff that you write can be applied across device families, not just one particular one. So like your code to fetch your, like I have this Inky frame here, and it's like, it's Wi-Fi code and an e-ink code, and it's running on a Pico W, but like the APIs are the same. So if I wanted to move it, you know, say an e-ink Wi-Fi board with ESP came out, like I could just move the code over and just be off and away. So I generally do, like, you know, I believe in the CircuitPython way. And I would argue that that's probably, like, CircuitPython itself is a bit stricter on APIs, so it's easier to do that with CircuitPython than it is with MicroPython, but only barely. Not by a lot. And obviously I have a bit of a bias as well. All right, so we'll see if this fixes it. That would be cool. And this should also include the tuning output. So it should tell us what settings it's going with, which would be neat too. This is kind of a long shot. It is totally possible it's our bug. But I don't think many of our ESP boards use octal RAM, and I think this or flash. I think this one could be a bit unique in that regard. And explain kind of why we're seeing this issue here, but not on a lot of other boards. But yeah, I think we could turn off timing tuning in the menu config too. We could just turn it down and see if the problem goes away. No. So Jacques says, might get me banned from this channel, but what would you say is the pros and cons of CircuitPython versus MicroPython? Also, micro.server and MicroPython, will it run on the same on, I assume, CircuitPython. We won't ban you. Generally the Adafruit philosophy is that we don't care what software you run on our hardware. Like ultimately at the end of the day, Adafruit makes money from selling hardware. So if you find MicroPython on our hardware to be awesome, then that's great. And CircuitPython wouldn't exist without MicroPython as well. But we've done a couple things specifically with CircuitPython on top of MicroPython to make it better in our opinion. One is that we are stricter about our APIs so that you know that the code will work across ports. There's a technical reason because we factor out that API layer and MicroPython doesn't. And then in CircuitPython, we've really put a lot of effort into what we think of as the first 5 minutes. So this is, and so our workflows are pretty good, I think, too. So I don't trust this flash because we're seeing the same error. This is interesting. PSRAM initialize caches in normal 1-core mode. But I imagine there's a world where, why is it in 1-core mode when we're on an S3 and we have 2 cores? That seems bad. Yeah, I thought they were removing the version 2. I'm wondering if I didn't flash everything successfully. Like I did a clean. Does it show me the version of elf file SHA? Yeah, IDF 630. So this doesn't look like it flashed successfully. Or I updated the IDF in the wrong. Yeah. I'm in CircuitPython 8. I'm in the different directory. Oh my gosh. That's super annoying. Okay. So I think what I do is I go in here, check out that. Oh, dang it. I have to do the same thing because apparently submodules are different. Do it again. Remote add espressif. I don't feel like my shell history has ever worked the way that I want it to work. And I've tried to figure out how to get it to work. It just doesn't work. All I want is a search, I think. Git fetch unshallow. Whoa. I just got a notice from the daycare saying, oh, what time did Ari wake up? Oh no. I thought he'd just woken up. He slept 2.5 hours. Okay. So I'm doing the same thing again. In a slightly different place, which is annoying. But this merge worked out pretty well. So we didn't put that much energy into it. Not something we could merge. Git fetch espressif. Yeah, one core mode sounds suspect, doesn't it? Control, like anytime you're passing buffers between the two, that could cause problems, which would happen with Wi-Fi stuff, but I'm not using bash, I use fish. But... all right. Okay, DA18. Clean. Flash. And it doesn't work. Okay, I need to update my IDF path. Great. I can do that. Put myself in bootloader mode. Deactivate. Doesn't work. I have a love-hate relationship with the IDF. Generally, we skirt around vendor things. Oh my goodness. How much did they change? ESP BT. I'm getting deja vu here. Huh. Why are we importing it? I hope this fixes the issue. I guess, you know, what I could do is I could just hack it for now. Don't have to fix it properly. Deactivate didn't do anything. It's supposed to deactivate your Python virtual environment, which I know that the export.fish sets up, I thought. That's why I tried to like get myself out of the virtual environment before getting into another one. But apparently they don't set it up that way. They have to do it differently. Yeah, virtual environments. Waiting for download. I hope this fixes it. A lot of people, like, going back to the microdot server thing, like, I know that's a MicroPython thing, but a couple people have put a lot of effort into HTTP server stuff as well. Okay, well, this explains what we're looking for. It is an ESP-BT. But we're not on... like... overflow. Test IDF size. I don't know where it used to be. I guess the expedient thing is just to comment it out. Power set 285. 285. 285. Is it just me or the screen freeze? Just David. Okay. Yeah, I thought about turning Beely all the way off, but I got lazy. I don't know. Path of least resistance. I don't want to change too much. Then I have to recompile the IDF too. I generally only, like, I have a 30 or 16 core Ryzen here, but I generally, when I'm building the IDF, I only do a single core because I don't trust the Makefiles to actually concurrently build correctly. Because we have this weird hybrid of like Makefiles plus the Ninja ESP IDF libraries. All right, let's see what happens. Okay, so we still aborted, and we corrupted at a very similar place. So it didn't fix it. Let's verify that we are... IDF 445, DA 181. So we are on the newer IDF. Cache is in normal one-core mode still, which again sounds bad. Here's the timing tuning index 5. Have you found using multiple cores compiles incorrectly? Oh, for most other builds, I'll use all my cores. It's just the IDF one that I've had problems with. It won't like destroy anything. It just won't work correctly. Or like, yeah, the build won't succeed if it's in the wrong order. Timing tuning index 5. Cache is in normal one-core mode. That is very suspicious to me. Let's do some menu config digging and see if we can't see cache settings. Instruction cache. Cache config. I don't know why. I think this could be a rabbit hole. I don't know what this tracks tracing feature is, but that's the sort of thing that could help us. .240 cache config. Here's SPYRAM config. Let's look here. Type of auto detect. Cache fetch instructions from SPYRAM. Cache. Allow external memory as an argument to task create static. RAM clock speed 40. Integrate RAM into memory map. Run memory test. All right, let's just turn it down and see what that gets us. I didn't see any config for the... Let's just turn it down and see what happens. Is there a text file that menu config uses that is easier to search? Menu config is derived from a bunch of kconfig files scattered across the entirety of the project. It's something that I've been working with for the IDF5 update. And then the outputs get written to the SDK config, but that only gives you the config line. It doesn't give you the descriptor stuff. Jacques says, I ran into problems with HTTP server with MicroPython. Is that something CircuitPython addresses with your references to Adafruit's work on the APIs? Thanks for not banning me, by the way. Well, yeah, I mean, we ban people, but we ban people for bad behavior, not for asking reasonable questions. I'm not, I've only really watched the HTTP server stuff. But it's Adafruit CircuitPython HTTP server. And folks have put a lot of work into it. And maybe Foamy Guy will cover it next week as well. But it's not really, when I'm talking about standardized APIs, I'm not really talking about that because for standardized APIs, I'm talking more like hardware interfacing, like I2C and SPI, than I am for than like socket level stuff. All right, any final questions? We are running up against our 2-hour window, and I really have no idea how long this is going to take me. It's great that I can reproduce it, but it's very weird. It's a very weird problem. So yeah, maybe it'll just work here because we slowed the flash down. So let's... Nope, we still aborted from a corrupt stack trace, and it's even happening earlier in our code than it used to. So it does do a memory test. That took almost a second. That's interesting. So if Unexpected Maker's watching, that could be part of what slows startup down is the SPI-RAM test. This 7 seconds is between waiting for download and me pressing the button. So that's not interesting. I suspect this backtrace will give us the same thing, but we could just double check. Yeah, it's like in lock acquisition still. I wonder if it's related. I wonder if it is this. So we have this callback critical. I wonder if we can't log during critical stuff. I wonder if we caused ourselves the problem by doing that. Because before the logging was pretty generous. I bet you that's what the actual backtrace is. Is there lock logic errors? Probably. And that's what I'm thinking with this logging is like maybe the logging is causing lock contention. like under the hood. There's also log early, which may not use locks, which could actually give us more information. Okay, let's just see what happens here. Oh, it's still going to crash. So we still had the problem, but we had the original problem. We're back to the original problem. We didn't log the background. Yeah, so like spy bindings construct done. We're not in background tasks. So you can see here that this is where the background is. The GitHub issue is number 8288. Unexpected Maker says, I generally have the mend test off. Maybe not in CircuitPython. Yeah, it looks like it's still on. That might be part of it. Corne says, and here I am still needing to wrap my head around that it is possible to use high-level programming languages on embedded devices. Really awesome. What is possible makes it so much more accessible. Yeah, that's the goal. And, you know, MicroPython deserves a ton of credit for making that a reality. You know, CircuitPython really builds on the VM that MicroPython created. All right, well, I don't know what to do. I might keep poking this. It's also Friday, so I may not. But I think I should wrap up the stream. So let's do wrap up. Like, if I thought I was close, then maybe I'd keep going, but I have no idea. So, oh, cat cam is still frozen. Still frozen and in my way. All right, so hello, goodbye. This is why I'm not gonna make any progress. Goodbye, everyone. Have a great weekend. This has been Deep Dive with Scott. I'm Scott. I work for Adafruit on CircuitPython. If you want to support me, support Adafruit. They pay me to do all this stuff. You can do that by going to the URL or to adafruit.com to purchase stuff. You can join us on the Discord chat, which is the middle chat here, anytime. That doesn't disappear during this after the stream goes away. You can go to adafru.it/discord to join that. Next week I will not be streaming, but Tim, Foamy Guy, will be streaming in this slot. Tends to do deeper dives into library stuff, which is also super cool. And hopefully I'll be back 2 weeks from now in my new space, which will be cool, and it's gonna be a lot of work. I have a lot of stuff here to go through and to bring over to the other space. But yeah, thank you all for watching. It's been great. And if CatCam were working, and maybe I could, let's do one more unplug. I kind of want to sign off by giving Spook some pets here. So we'll see. Nope, it's still frozen. I got so excited when the image showed up. No, I don't know what the deal is. All right, well, sorry. Sorry, no CatCam. Good riddance. Good riddance, CatCam. Anyway, I suspect this logging panic is actually due to this print. But yeah, welcome to the weeds. Welcome to the deep dive in CircuitPython, where we don't always find our issues, but it was nice to be able to reproduce it. Like, issues that you can't reproduce are just like extra impossible. So let me just take one last look. Mike Jones says, high-level programming languages is why I don't understand anything what I'm doing. I'm enjoying actually turning on the timers and setting things up manually, and now looking at how CPUs actually work. That is I totally agree with you. That's exactly why I like working on CircuitPython, is because there's no OS below us. Like, that's pretty much it. And we have looked at or we've started to allow you to do memory map access, so you could actually hit registers straight from Python too. So if that's interesting to you, take a look. We have it in a couple ports, but we could add it to more. And it's pretty straightforward to implement. Anyway, see you in 2 weeks, hopefully, assuming all the internet and moving goes well. And I'll see you on the Discord before that. So thanks, everybody. Have a great weekend, and we'll see you next time.